Okay, now all the information are given, shown here. If this the equal length given is QP, RS and QR equal length. So this is also 9 cm. Sorry, rub off. Okay, so this should be 9 cm. And then you say that these two lines are parallel. Okay, if these lines are parallel with this, and you have this transversal, that means to say this angle is actually equal to this angle. They are actually alternate angle. Okay. Now, what else? And okay. Now let's look at a question. Angle SQR, SQR. So we find this angle. Angle PSQ. PSQ. We're supposed to find this angle. Length PQ. We're going to find this length. Then length PS, which is this. Okay, and find the area of PQRS. That means the whole quadrilateral. Okay, now to find the quadrilateral, there's no formula to find as we can see in here. But we can actually split into two. This A, this B. Okay, A. If you have found this length. Okay. What is this? So we'll find this. Okay. Now, if you can find this length and this length, okay, then this will be the base. This is the height, or this is the base. This is the height. Doesn't matter. But it's a right angle triangle. So to find the area of A, it's very straightforward. It's a triangle, so it's half times PS, okay, times PQ. That's it. That is for area A. Area B, if this isosceles, this also equal to theta. If you find this angle, okay. To find this area B, we will have to do this at this stage. Actually, it can be calculated much earlier. But what happened is now we are looking at trigonometry using the cosine and tangent. So we're going to solve it using this. Now, let's say if this isosceles, that means equal length. So let's drop a line vertical, the height from here, and that will equal to 90 degrees. And then this will be split equally, so it becomes 6. Oh, sorry. It should be written 6 cm here, 6 cm here. Now, if you look at half of the triangle, okay, no, if you look at half a triangle, you get a 90 degree here. Now, if I have this length and I have this length, this hypotenuse of this triangle, this is one of the shorter length. You can find this height, R to the midpoint of 16 cm length. They will give you the vertical height, and then you got a base 12 cm. From there, you are able to calculate the east area. Okay. So area B is equal to half times the base is 16 from here to here. Sorry, 12. And then times the height is from here to here, which we're going to calculate out. Okay? So that is the vertical height. Now, let's start with calculating SQR. SQR. Okay? Now, SQR. By SQR, based on this triangle here, I have a 90 degree, I have a 12 cm. That's it. Don't have third piece of information to calculate this angle, SQR. There's only one piece of information, two pieces, right angle and 12 cm. Remember, we talked about to find the other three unknown parameter, you have to have three given parameter. So we have 1, 2. So you don't have the third parameter in a right angle triangle. So you couldn't find any of this length yet. Okay. So what we're going to do is we're going to look at the other triangle. Okay. The other triangle seems to have more information. You have this 9 cm, you got this 12 cm, and if you have a vertical line down from the vertex of isosceles triangle, then this becomes the vertical, and then splitting the base 12 cm into two equal lengths, which is 6 and 6. Okay. Now let's look at the triangle over here. I have a 90 degree, I have 6 cm here and a 9 cm. So I have three pieces of information given for this triangle. Therefore, whatever angle we want to find, whatever length we want to find, we will be able to find it with that three given piece of information. Okay. Now, we're going to draw this triangle. So we have it here. Got a 90 degree, 6 cm, and then a 9 cm. I want to find this length, the vertical height. Okay. Now you got 90 degree, you got this longest length, hypotenuse, and then these two are the shorter length. Okay. Let's call this as, put here O. So this become R, O, this S. Therefore, let's using Pythagoras. Remember the word Pythagoras. Oh, it's too small. You couldn't. Okay, never mind. We're going to write it over here using Pythagoras theorem. So SR, which is the hypotenuse, is equal to SO. We call this one O. SO square plus OR square. What we want to find is OR, which is the vertical height of triangle SQR. So this is actually unknown. Let's make this unknown the subject. OR square. OR square. OR square is actually SR square. This bring over, so it's SR square minus SO square. Then we interchange the place. So SR square is 9 square minus 6 square. Okay, this 81 is 36. They give you 45. Okay, now therefore OR is actually square root 45. Okay, we do not need to find this value. Just keep this value. Afterward, when we want to find the area of this, and we're going to use the OR, then only we calculate. Okay. So we got the length. Okay. Now, what about SQR? SQR actually is same as RSQ. Okay, that's going to work out this angle, theta. Okay, now, what are the given value? T is the opposite of this angle, opposite. This is going to be the hypotenuse. So you got a H, you got a O. So what are you going to do? So, katoa. Oh, sorry. This adjacent, the adjacent. Okay? You got a A, you got a H. So this is actually SOH, CAH, TOA. So you got an A, you got a H. So you're going to use cosine ka. So cosine theta is actually adjacent over hypotenuse. In this case, adjacent is equal to 6, hypotenuse is equal to 9. Simplified, become 2 over 3. Okay. Therefore, the angle theta, which is actually equal to angle SQR, so this becomes cosine, arc cosine, 2 over 3. Oh yeah, 48.2 degrees. Remember, IGCS standard is for angle is 1 decimal places. Okay, I mean this angle is 48.2. This is also 48.2. Okay, we also work out this length. OR is square root 45. Now, we're going to go back to the alternate angle. Since it is parallel, therefore this angle is also equal to 48.2. Okay, so SQR is equal to 48.2 PSQ. PSQ. Okay, now let's talk about in triangle PSQ, this angle plus this gives you 180. Okay, the main angle PSQ plus 90 degree, then plus 48.2. Equal to 180. Okay. Therefore, angle PSQ is equal to 180 minus 90 minus 48.2. And that gives you total 180 minus 90 minus is 40. 41.8. Okay, this become 41.8. Okay. Okay. So PSQ is 41.8 degree. Remember putting the unit, which is the degree. Now PQ, if you have the angle and you have 12 cm, you should be able to find the PQ and the PS. Okay. Now let's do it over here. Okay, this SP, this Q, this 12, this 48.2. Okay, now we're supposed to find this length and also this length. Okay, let's talk about this length. This length is, with respect to this angle, is the adjacent. Given is this one is the hypotenuse. Given. Okay, so you have a A, you got a H. So we are using CAH. C-A-H. CAH means cosine of 48. The angle is equal to opposite, which is PQ, over the hypotenuse, which is SQ, which is equal to 12. Therefore, PQ is equal to 12 times cosine 48.2. Then similarly, if you want to find PS, it's very simple, because PS is the opposite. So opposite is actually OH. So it's 12 times sine 48.2. Okay, now so you're going to find this value and put here, and then PQ you're going to put here, so you can find the area A. Now the area B, which is a triangle also, is half times the base, which is 12. The vertical height, basically just now we work out the OR, which is square root 45, half times 12 times square root 45. Okay, now once you find this and this from here, you add together, that will give this